Okay, so now I'm about to give you the very key thing about this topic now, okay, that I want you to so much understand, okay? And it's not usually written in the notes, but you have to know that this is a key thing here. The moment you understand this, everything is going to become very simple for you when it comes to simplifying square roots. And this is the one thing that I want you to write down, okay? It is what is known as the perfect square, okay? Once you understand what this is, everything then becomes sour. No, it becomes sweet, isn't it? All right, so let us look what a perfect square is. By definition, a perfect square, okay, you can write down to say perfect square is a product of an integer multiplied by itself. Or you can just say it is a number that can be expressed as a product of an integer multiplied by itself. If I say a product, anyways, I've said it, I've multiplied, isn't it? So you can just write this down. A perfect square is a number that can be expressed as the product of an integer by itself. I'll repeat that. A number that can be expressed as the product of an integer by itself. All right. So what do we mean by that? A product of an integer by itself, isn't it? So if, for example, you have 2, so you know that 2, if you multiply it by itself, what are you going to get? You're going to get 4. So meaning 4, if you look at the definition, is the number that can be expressed as a product of an integer by itself. So you call 4 as a perfect square because it is a number that you get after multiplying 2 integers. All right. So if, for example, we have 5 and you multiply 5 by itself, isn't it? We're going to have what? We're going to have 25. So you have all these perfect squares. And just for clarity's sake, I think I would love, because you're not going to be using a calculator, I would love you to know at least maybe the first 15 perfect squares, okay? So for example, you're saying 1 by 1, 2 plus 2, 2 times 2, 3 plus, I know you know these, 6 by 6, you know it's going to be what? 36, 7 by 7 is 49, okay? All know all these perfect squares, okay? 8 by 8, you know, is 64, isn't it? We've been doing this from grade, I don't know, 9 by 9, we know we have a number, 81, and we can go on and so on, 110 by 10, and all that. So all these numbers here will be called to be what? To be said that they're perfect what? Perfect squares. The moment that you have this knowledge, everything else then becomes very simple. So now let us get back to the question that we had. So the way that they're going to be giving you these questions is they're going to ask you to simplify the radical expression. Okay, so they'll give you a number and they ask you to simplify, and I'm sure you have these. Okay, sorry for that. My internet had cut. So now let's just do some examples of how you simplify these expressions. So remember our previous example, we ended on, I think we had 3/2, right? What did we have in our previous example? Where did we end? I think we had something like 12/8 and then root of 8, right? We had this, isn't it? So now this answer is not final. You need to keep on, okay? So this, we said you can simplify this, isn't it? This is just the same as 3/2, then root of what? Of 8. Now, when you reach this point and you leave this as your final answer, this is going to be marked. You're not going to be given full marks. Okay, so to get your full marks, you need to simplify this further. Okay, by saying, if you look at 8, in what ways can we express 8 as a number that is containing a perfect square. So which perfect squares can go into 8? Yes, anybody try it out? Which numbers can go into 8? Which perfect square? So we know the perfect squares are 2. We know we have 1, 4, not 16. So 1, 4, what was the list that we put up? So you have 1, 4, and you can go on and so forth, isn't it? But one of the ways we can express this as a perfect square, we know that there's a perfect square that goes into 8, and that is what? 4, isn't it? So you know 4 can go into 8 2 times. So you can express this 8 as root of 2 times 4, isn't it? You know that this is the same as 8, right? So you can now separate this. This can be equal to 3 divided by 2, right? Then we can separate these two and say root of 2 multiplied by the root of what? By the root of 4. Then you know that this number here can give us a 2, isn't it? So this is the same as 3. And then the square root of 4 is 2. Then you have the root of 2 divided by what? By 2. What is this? 3 by 2 is 6, isn't it? So this is our end answer is going to be 6 divided by 2 root of 2. Then 2 here, 1, 2 here, it's 3, right? So the final answer therefore is going to be 3 root of what? Root of 2. Then you leave it this way. Okay. So the most important thing when you reach this stage is asking yourself which perfect square can go into 8. The highest perfect square, that is. All right. So let us go ahead and do another example. All right. So let's say we are taught to simplify. Okay, maybe let me pick out, I think I have an exam question here so that I show you how these questions will come. Or maybe before I go to this, I should have just done this so that I get done completely with the basics. Huh? All right, let me just look for one question. All right, let's say we have the root of 18. They give us this to say, simplify the root of 18. Okay, so one of the biggest, the first thing that you have to do is you look at 18, then you ask yourself which perfect square can go into 18. What's the perfect square that can go into 18? So you know we have perfect squares, you have 1, we have 4, which other one? And the very 18, isn't it? 9, right? So among these perfect squares, which can go into 18, which one is the highest? You know that the one which can go into 18 without leaving a remainder is 9, isn't it? So 9 into 18, you know that it's 2, isn't it? So it means 18 is just the same written as 2 by 9, the root of 2 by 9. So this will be equal to what? You can separate this according to the product rule, isn't it? We can say root of 2 multiplied by the root of what? 9. Then this can be simplified as root of 2 multiplied by the square root of 9. You know that it's what? It is 3. Then you can leave it as 3 root of 2. Then you have simplified. So the most important thing is knowing which perfect square can go into that number without leaving a remainder. Okay, and usually they would give you smaller numbers, and from those smaller numbers you can be able to simplify. So for example, here I want us just to try out this. You can pause the video if you are watching the recorded class. So if we have this, for example, I would just want us to try it out. Try out 12, the root of 12. How can you simplify this? They give you simplify this. This will be called what? You can check the perfect square that can go into 12 without leaving a remainder. And if there are 2 of them, let's say, you go for the highest perfect square. So you know that this, we can have a perfect square that can go into 12, which is 4, isn't it? So 4 into 12, you know that it's 3, right? So this is just the same as 3 by 4, right? Then you can separate this. This is going to be root of 3 multiplied by the root of what? Of 4. You know that 4 is a perfect square, so this will give us 2. So 2 root of what? 3. It can be expressed like this. Then you have simplified. All right. So we'll do more questions on these. I have a good number of practical questions. And I should mention that I'm going to give you a quiz on Friday. We'll have an online quiz. So everyone is going to write, I'll set it as standard as the UNZA one. Okay. and then I'll give it to you guys so that you can have a feel of what you're going to write or what you're going to expect there. So let us look at now at the last thing, which is called the conjugate, okay? Then we'll do the practical applications when I come on Thursday. All right, radical, we're looking now at conjugates, huh? Now, let us write this. A radical expression, so you can just write this to say a radical expression, just write this down. A radical expression that involves, so a radical expression that involves addition or subtraction. So a radical expression that involves addition or subtraction of the same two terms, of the same two terms. So I say the radical expression that involves addition or subtraction of the same two terms is called conjugates, or are called conjugates. Okay? And this is the word conjugates. Okay? Okay, what is the problem? All right, so I was talking about a conjugate. Huh? So the conjugates, I say this is an expression that involves addition or subtraction of the same two terms. All right, that's a conjugate, right? So for example, here, you've seen that when we're dealing with that one, we're only having, let's say, for example, the root of 2. Let's say we have 1 over the root of 18. That's what we're dealing with, isn't it? But now for the conjugate, what if you have something like this? They give you 1 over 1. Okay, let's say 1 over the root of, let's say you have 18 minus 1, all right? Or let's say you have 2 over the root of 3 minus 1, something like this. So you can see here that we have two terms, one term and the second term. So such an expression that contains two terms, you're adding them or subtracting them. So here, whether you're adding, whether you're subtracting or adding them like this, you call this expression. How you're going to get rid of this square root by rationalizing is that you need to use what is known as a conjugate. So remember the last time we were doing that, the first time we're just multiplying by the root of 18, for example, here, and root of 18, isn't it? But for the conjugate, when you're having something like this, an expression that has this, you need to multiply by its conjugate in order for you to get rid of this square root. So how are we going to do this? For example, if they give us such an expression as this and they ask you to simplify it, what you need to do is multiply this by its conjugate. Now, its conjugate would just mean the same expression that you have down here, but it just changes the sign. So for example, here, the conjugate of root of 3 plus 1, the conjugate is root of 3 minus 1. That is what this is the conjugate of this. Then you call these two terms as conjugates. All right. So now I must emphasize, I want you to try out this, all right? Just in your own time. I think I can leave this to you guys as an exercise. Okay. Okay, let me just do this. I want to leave this as an exercise for you. What numbers do you get when you have, for example, you have A, okay? Let's say you have A plus B multiplied by what? A minus B. That's what we're dealing with here. So this is just the same as you multiply A times A, which will be A squared, isn't it? Then A times this B will be negative AB, right? So you multiply A times everything, and then you get B again times everything. So A times everything there is A times A, which is A squared, minus A times negative B is negative AB. Then B times this will give us plus, we're going to have AB, isn't it? Or BA, it's the same thing. Then again, we're going to say B times this, we're going to say minus what? B squared. So you can see from there that these two terms are the same, and this is negative, this is positive, so they'll just cancel out. So this will therefore just be equal to A squared minus B squared. So what does this leave us with? Whenever you're multiplying a conjugate, the only things that we're interested in are the first two terms, the two terms themselves, they're going to subtract each other. So it's the same thing when you have the square roots and all that. So for example, if you have this square root here, let's say you have the root of A plus the root of B. So this you multiply by the conjugate, you're going to say multiply by what? Root of A minus the root of B, isn't it? Like this. So what's going to be our final answer without even calculating? When you do A times this, if you have this, for example, is the same thing that we're having. The only thing that you're going to remain with when you do the multiplications is that you're going to find A times, it's just going to be the root of A. You just get the first terms and square them. What's the other term? Is this one. So you get the first one, you get the positive one, then the second one, you just get the negative. So you're going to say minus the root of what? B squared. So you know that the square roots and this will just cancel. So we're just going to remain with A minus B. So this is going to be our final answer. All right. So whenever you're just multiplying the conjugates, just remember that the only answer that you're going to get, I was just erasing quickly for the sake of time. So you can watch the recorded class if you want to put down those notes. All right. So just know that whenever you have this, so I just want us to try out this in just a minute before I get to close. Let's say I've got this root of 3 plus 1. So this multiplied by its conjugate, you know that it's just going to be what? Multiplied by, so if we're multiplying by its conjugate, it's just going to be the root of 3 minus 1, isn't it? This is the conjugate. So you're multiplying conjugates here. So like I said, instead of doing all those multiplications and going, you know that the conjugate will just give me what? This will be the root of 3, then you square it, right? Then you get this other expression for the negative one. So you're going to say minus, we're going to have 1, negative 1 squared, isn't it? So this, you know that it's just going to give you what? These square roots will cancel. So you're just going to remain with 3, right? Minus this 1 squared is just 1 times negative. It will just be minus 1. So this will just be equal to what? To 2. All right. So that is all that is there when it comes to conjugates. And you can be given something like this. Maybe we just do one example. Then on Friday, as I come, I'm sure you'll be ready for the quiz. Actually, we'll finish and we're going to do 1 hour. We'll do the square roots of i's and stuff, the complex numbers. That has a lot to do with what we're doing right now. So let's say, for example, you're now given an expression to say, let's say 2 over the root of 3 plus 1. And they tell us to rationalize the denominator here, all right? Or simplify this. So you know that you need to get rid of what? The square root here, isn't it? That's rationalizing. So what are you going to do? You multiply both sides now, not only by square root of 3, but by the conjugate of this. So now you're going to multiply this side by the conjugate. You're going to say root of 3 minus 1, okay? And also here down, you're going to multiply by the root of 3 minus 1. So you know that the conjugate is going to give you what? When you multiply the conjugates, you can just get the root of 3, okay, squared. And then this is going to be minus negative 1, what? Squared, isn't it? That's what the bottom part is going to be. But I should have started with the other one. So let me first begin with the top part. So the top part is going to be 2 root of 3, right? Minus 1. So you know this is multiplying this, isn't it? Then I'm going to say divided by. Down there, we're just going to have 3. You're going to have the root of 3 squared. So you just get the 2 terms minus negative 1 squared. So this is just going to give me 2 times this is just going to be 2 root of 3. Then 2 times negative 1 is just going to be minus 2. Then we can say this over. Then here we're just going to have 3 minus 1, 3 minus 1, which is just going to give me the root of 2. Sorry, this is just going to give me 2 root of 3 minus 2 divided by what? 2, isn't it? Then you can see these two, and these two can cancel. So therefore, final answer is just going to be root of 3 minus 2. Then you would have rationalized or simplified. All right, so just know whenever you're given an expression like this down, okay, just multiply by its what? Its conjugates. So other than that, we are going to leave it there, and we are ready for all the questions that can be asked on concerning the square roots. So on Thursday, this is the way that we're going to plan. I'll come with exam questions, and in the first 1 hour, I'll first introduce you to the complex numbers, which are numbers that just have to do with i's, okay? The complex numbers, and we'll do the complex numbers in just 30 minutes. The other 30 minutes, we're going to use it for doing this, okay? The practical now, how to simplify these radicals in terms of, I'll give you exam questions. We can just practice that. Then the other hour, if we're going to have more time, if time allows, then I can give you the very quiz, but I think it won't be perfect for that day. I can just do enough questions with you guys. We do the revisions of the number lines and everything, because by this time, we're done now with everything that is going to be given in the quiz. So ensure that on Monday, on Thursday, you're on time, then that's the way that we're going to run. Okay, so that is all about today's class, but too bad we didn't remember to pray. But I'll just get to close with a prayer, and then we can meet on Thursday. So tomorrow we'll meet for economics. Then Thursday we'll meet for, yeah, is it Thursday? Yeah, Thursday, 14 hours. We're going to meet for mathematics. All right, unless there's a question, or I can get to close.
-1.
Okay, actually, that's a very, very good thing that you've mentioned. I should have forgotten to do this. So what you do is actually, I was biased when doing this. So you don't put it this way, all right? Because this 2 is dividing everything, isn't it? So what we're
Yeah.
going to have, this is not going to be our final answer. So this is just the same as, okay, that's good. So this is the same as 2 root of 3 divided by 2, right? Then minus 2
Yes.
divided by 2, like this. All right. Then what are we going to have here? We're just going to have the root of 3. Then these 2's as well will cancel, isn't it? We're going to have -1. So this is actually our final answer. So when you reach this point, I just forgot to mention, when you reach this point, you need to separate them. Okay, so let this one which contains the square root have its own, and then you'd say minus, then the other one as well, like this. Then you can simplify it in this form.
All right.
Yeah. Anything else? Thanksgiving our hearts. Amen. All right, so please just make sure that you pass through this, and we won't have problems on Thursday. So ensure that you have all the skills at the tip of your hands. We'll see you on Thursday. Have a blessed day.